Hello, everyone, and welcome to your first edition of Flip Notes for this year's geometry class. Our topic is polygons, something that we talked about earlier in class today. And by definition, we kind of came up with what we thought a polygon was. This is the formal definition. It's a closed figure defined by the number of sides and angles that it possesses. We have several different examples of polygons. So you can pick any one of these or draw your own to give an example of a polygon. Of course, it can't contain any curved edges. All the sides have to be straight, and it cannot be an open figure. It has to be closed. To name a polygon, we use the vertices. So the vertex of a polygon is any corner or any point where two sides intersect. We name these points with capital letters, and to name a polygon, we just name it by its number of sides, and then we go around at any point clockwise and list out all of its vertices. So this one I've named decagon A, B, C, D, E, F, G, H, I, J. Keep in mind, though, that you can still name this polygon using any of the points as a starting point. So for example, I could name it with point H starting first, but I still have to go clockwise. That's the rule. So I could also call it decagon HIJABCDEFG. Okay, so polygons have certain things in common. They're always closed figures. They can never contain any curves like in a circle or an oval, but they do look a lot different. So we have a couple of different ways that we can describe them. So a polygon can be either convex or concave. A convex polygon is kind of the ones I feel like we're more used to seeing. There are polygons where the lines containing the sides of the polygon never extend into the interior of that polygon. So what that means is if I were to extend a side of this polygon, any of the sides, the line would never go anywhere inside the polygon itself. So that would be considered a convex polygon. Whereas this polygon right here, if I were to extend this side, do you see how it extends into the polygon itself? So that would be an example of a concave polygon, or a polygon in which there are kind of dents or caves in. So please, under the definition of convex and concave, give an example picture of one of each. So these would be the two concave ones, and these would be the two convex ones if you wanted to use one of mine. And the other way that we can describe polygons is by either being regular or irregular. So a regular polygon are the cliche polygons that we always think of. There are polygons that are both equilateral and equiangular. So like the octagon in a stop sign has all congruent sides and all congruent angles. That is a regular octagon. An irregular polygon is the opposite of that. It's something where at least one side or one angle is not congruent to the others. So if we take a look at our examples up here again, the regular polygon is the triangle. So this is the only polygon up here of the four that has three congruent sides and three congruent angles. This one clearly is not regular. This one is not regular because the sides of the quadrilateral are not congruent to the top or the bottom, and the top and the bottom are not congruent to each other. And this one at first glance kind of seems regular. It's, this kind of nice star. Um, and because all of the sides are congruent, it can be confusing. But the angles are not congruent. If we look at angle C and we look at angle B, those are two very different angles within that decagon. So while it is equilateral, it is not equiangular. So it cannot be regular. I'd also like you to take a few minutes to fill out the chart on the back to name all those polygons by their number of sides and to take a look at the key terms on the back of the notes also, and make sure that you are able to use those terms in conversation to describe an answer or a polygon or anything like that. Be familiar with it in order to use it. And I will see you guys next class.